Good morning, everyone. Welcome to Monday. Hope you've all had a lovely weekend. Thanks for all the work you sent me on your parallel and perpendicular lines last week. It was looking great. We're moving on this week, though, to look at some polygons, irregular and regular, and we're going to be doing some work with some 3D shapes. So I had to go at recording this video earlier because I had a brilliant link to a BBC bite-sized video that's really good as a recap, because I realised we haven't really looked at polygons for ages. So what I'm going to have to do is share my screen. So I'm just going to go very small and show you one here. Now, I tried playing this, but it didn't seem to video and properly, and the sound was really dodgy. So if you're on the internet, you could copy and paste this link, and it will take you to this site where it's about how to identify different polygons. And there's a really good video. It's quite funny, a bit silly. It's only a minute and a half, but it might be a good idea to pause this video and watch that first if you can. It doesn't matter if you're happy to carry on and watch it later, but it is quite a good way of remembering what we are doing. Okay, so we're going to move on then today to having a look at polygons. And let's think a little bit about what a polygon is. A polygon is a shape that has straight lines, has to have straight lines. You'll see that the circle gets into a bit of trouble in the party at the video on the bite size video. And so they have to have straight sides, and those straight sides have to meet to form a shape. Now, if they're regular, they all have the same length of sides and the same length, size of angles, and if they're irregular, the lengths and the angles are different. Okay, so let's carry on. So here we are. Now then, so what we're looking at is reasoning, first of all. Oh, sorry, this is the wrong one. Hold on, let me go back. That's not what we're looking at. This is where we should be. Okay, so we're looking at regular and irregular polygons. Now, here we've got Isla and Richard, and they are looking at this shape down here. Now, Isla is saying all the interior angles are the same, and Richard is saying, I think this is a regular octagon. Now on the right hand side, we can see it says regular shapes have all angles equal and all sides the same length. And at the bottom, there's the girl saying, I know that if the angles are not the same or the sides are not the same, then the shape is irregular, which is what we've just seen on the little video. So let's have a look carefully at this shape. And what do you think, looking at it? Do you think it is a regular polygon? Is it a regular octagon, like Richard is suggesting? Now, when we look closely at it, let me see if I can try and make it a little bit bigger. Okay, not very much, but a little bit. You can see that these lines here at the top, they go across, and they look like two squares along. Whereas some of these down here, are they still two squares? I think so. They're going across diagonally with two squares. The difficult thing is to know about the angles, isn't it? To know, are they the same? And obviously, we've talked about this before. It's a little bit tricky at the moment when we're away from school because we haven't all got a protractor. But if we have a look at this next slide, it's saying here that there's different ways you can measure the angles. So here, he's used a protractor. All right, and it's very, very tiny, but it's showing that the angle is 135 degrees. Now, this girl here has spotted quite cleverly that each angle is made of a right angle and then like a square cut in half. And we know that from looking at this before, that if you've got an angle that's going straight through a square like that, it's going to be half of that right angle. So half of a right angle, half of 90 degrees is 45 degrees. So there, she's used a bit of her common sense in estimating. She hasn't got a protractor, but she's used a bit of a thought process there that's actually helped her come up with the right answer. Now, we can see that there, Mrs. Lodge said on the first slide, oh, look, there was two squares going across. Is the diagonal angle, it's going across two squares, so is that the same? But actually, look, when we measure it with our ruler, this one is actually 3 centimeters long, and this one is 2 centimeters long. So it isn't a regular octagon. Why? Because the sides are different lengths. The angles might all be the same, but the sides are different. Therefore, it's an irregular polygon. That's what we have to remember. Okay, so let's have a look together on this slide about these shapes. So it says, explain why each shape is irregular. So this first shape here we've got is a rhombus. Now, why is the rhombus irregular? It looks like all the lengths are the same. If I could hold a ruler up, I'd measure those, and I have measured them, and they are the same. However, which other part do we have to look at? We have to look at the angles. Now, you can see at the bottom here that the two lines that meet, they're quite wide apart. That looks like an obtuse angle because it's greater than 90 degrees. Whereas these lines that meet in the middle, they look smaller, don't they? They look like an acute angle. They're less than 90 degrees. So therefore the rhombus is irregular because the angles are not the same. Now the rectangle, we can see that all the lines there, the edges are all meeting to make a 90-degree angle. So the angles are the same, but what about the lengths? Let's have a think about the lengths of these. So these ones are shorter and these are longer. The width is shorter, the length is longer. So the rectangle is irregular because the lengths are different. And the hexagon is a little bit like the octagon. Have a think, why do you think that might be irregular? What looks different to all of these? Again, it looks like the lengths, doesn't it, to me? Because these are two squares, but I think if we measured this diagonal side with a ruler, that would probably be longer, therefore making it irregular. So this is what your work is today, and you're going to be going into your Power Maths books. I haven't got the page numbers in front of me now, but that's all on the email that I've sent to your addresses, and you'll be able to see the title. It's called Regular and Irregular Polygons, and you can start to work through that. Remember, if you haven't had the opportunity to collect your Power Maths books, all these pages are copied and attached to your email, and you can work through as much as you can. Now, obviously, we all know the challenge is a bit more tricky, but if you get that far, have a go. Even if it's not right, it doesn't matter. It's a really good idea to have a try at the challenges, because I think often you'll surprise yourself with what you can do. And always remember to have a go at the reflect at the end. Now, one little thing I'd like you to do for me is that before you send me your work, if you could mark your work, it's really helpful for you to do that before you send it on, because then you might go, oh, that's wrong and I'm not sure why. So when you're sending me the work, you could ask me that question whilst you're emailing. So I'm going to go back to my big screen now. So have a go at that for the regular and the irregular polygons on Monday. Please send me some work. We're doing the Friday feedback show this week, so anything that you send me could feature on there. And good luck, and I will see you again tomorrow. Okay, bye-bye.